In today's video, we will discuss all about cool integer functions in Python. If you are interested, then keep on watching. Hey champions, welcome back to this channel. Hope you are taking care of yourself and your loved ones during these times. You can subscribe to this channel for more such videos. Without any further delay, let us get started with the video. Starting from the basic can make tougher things simpler. Here is a brief description about function. A function is a block of related statements designed to perform some task. It only executes when it is called. The main purpose of the function is to reuse code instead of typing it again and again. Functions can be both built-in or user-defined and take inputs which are known as parameters. They may or may not return anything depending on the user requirement. Syntax of a function is quite simple in Python. It has a def keyword followed by a function name. The def keyword tells the Python compiler that we are defining a function, and name of the function help identify it uniquely. It is then followed by a docstring which defines the function, and then are statements which will perform some task. We hope that was helpful for you, as we will cover functions in detail in some future video. Now moving on to the integer functions that we will be discussing in today's video. First is as integer ratio, next is bit length, third is conjugate, fourth is denominator, fifth is numerator, sixth is 2 bytes, seventh is from bytes, eighth is imag, and ninth is real. Before we start with the functions, let us see how to check all the functions associated with an integer. For that, write an integer and then press tab after the dot. Easy peasy, right? We will now start by describing each function in detail. First is as integer ratio. This function returns a pair of integers whose ratio is exactly equal to the original float and with a positive denominator. Also note, for an integer, this function will always return the integer as the numerator and 1 as the denominator. Example is a equals to 3.5. This integer ratio is called on variable a, and see what exactly does b displays. B returns the reduced fraction form of 3.5, which is 7 and 2. We can also separate them out by calling the 0th and the first index of the stored variable. Look how it displays 7 if we call b 0 and 2 when we call b 1. Second is bit length. It returns the number of bits necessary to represent an integer in binary, excluding the sign and leading zeros. Let us take an example of a equals to 4 and let us see how it is represented in a binary system. It is represented as 2 raised to the power 2 into 1 plus 2 raised to the power 1 into 0 plus 2 raised to the power 0 into 0. Now when bit length function is called on variable a, it gives us 3 as the answer, proving that we indeed need 3 digits to represent 4. Also note, if a is 0, then bit length returns 0. Third function is conjugate function. This function returns the conjugate of any complex number. The conjugate of a complex number is obtained by changing the sign of its imaginary part. Example, if the complex number is 2 plus 5j, then its conjugate is 2 minus 5j. Similarly, if the complex number is 5 minus 8j, then its conjugate is 5 plus 8j. Next function on our list is denominator function. It returns the denominator of a fraction. In this example, we have first imported the fraction class to declare the fraction, and then we will call the denominator function on it. Variable a is our fraction with numerator as 1 and denominator as 5. 5 is returned when the denominator function is called on it. Next is numerator function. This function is quite similar to denominator function, but instead of the denominator, it returns the numerator of a fraction. Looking at the previous example, the numerator function will return 1 as the answer. Next is 2 byte function. This function takes argument from the user. This function returns an array of bytes representing an integer. Byte representation has the value from 0 to 255, that is from 00 to FF. 1 byte has 8 bits. That's why its maximum value is FF. This function is used where you need to convert bytes or byte arrays to integers for further data processing. The function has 3 parameters. First parameter is length. The integer is represented using length bytes. An overflow error is raised if the integer is not representable with the given number of bytes. Next parameter is byte order. The byte order argument determines the byte order used to represent the integer. If byte order is big, the most significant byte is at the beginning of the byte array. array. If byte order is little, the most significant byte is at end of the byte array. Third parameter to this function is signed. The signed argument determines whether 2's complement is used to represent the integer. The default value for signed is false. Here in the example, we can see how 16 is represented in the byte representation. In the first part of the example, we have given byte order as big, that is, we are instructing Python that the most significant byte is at the beginning of the byte array, while in the second example, we have given byte order as little, that is, we are instructing Python that the most significant byte is at the end of the byte array, and look at the difference in the result. Next on our list is from byte function. This function also takes argument from the user. This function returns the integer represented by the given array of bytes. This function also has three arguments. First is bytes. It must either be a byte-like object or an iterable producing bytes. Next is byte order. It determines the byte order used to represent the integer. If byte order is big, the most significant byte is at the beginning of the byte array. If byte order is little, the most significant byte is at the end of the byte array. And last is signed argument, which indicates whether 2's complement is used to represent the integer. In our example, we have given a byte sequence to this function with byte order parameter as big, and it returns 16 as the answer. While when we pass the same byte sequence with byte order as little, then the answer returned is 4096. Moving on to the next integer function, which is imag. Now, as we know, all complex number have a real and an imaginary part. The imaginary part contains j appended to a numeric literal, which is then added to an integer or float to get a complex number. To extract these parts from the complex number, we have real and imag function in integer class. For example, we have a complex number 1 plus 2j. To extract the imaginary part, that is part with j in it, we can call the function imag on variable a, and the result is 2. Extension of this function is real function, which is used to extract the real part of any complex number. In our previous example, if we call the real function on variable a, then 1 is returned. That is it for today's video. I hope the video helped you understand some cool integer functions. You can share your thoughts or questions in the comment box. Subscribe for more such videos. Bye and meet you in the next one.